So to solve a quadratic inequality in one variable like this, x squared is less than negative 3x minus 2, really what we need to do first is solve the quadratic equation that's related to that. So if you forget about that less than sign and change it into an equal sign, do you know how to solve that? X squared is equal to negative 3x minus 2. We can solve a quadratic by factoring or using the quadratic formula or graphing. There are a lot of different ways, but I'm going to do this by factoring, and the first thing I need to do then is take that negative 3x minus 2 and move it to the other side. So I get x squared plus 3x plus 2 equals 0. And like I said, I'm not even worried about the fact that it's an inequality yet. I'm just using equals. Factor that, x plus 2, x plus 1. And what we get out of that are our critical values. The critical values are the values of x that you get. So we get x equals negative 2 and x equals negative 1. It's kind of similar to when you're looking at graphing an inequality in two variables. The first thing you come up with is this boundary line. These critical values are the boundaries of the solution set. Once I have my critical values, with a quadratic, I could get 0, 1, or 2 critical values, but 2 is going to be the most common. I'm going to make a number line with those values on it. And really, those are the only values I'm going to put on it. I just need to make sure which ones goes to the left and which one's to the right, so the smaller number and then the bigger number. And I'm going to do the same thing again with those testing points. But I'm only testing one value, an x value. Actually, I'm going to test 3, but one at a time. I want to test something that's in this region. So remember, this is a number line. I want to test something that's in this region, something that's in this middle region, and something that's outside there. So what would a number be that I could test that's in this region? Any number at all. Negative 3? Negative 3 will work. I could have picked negative 10, I could have picked negative 5, anything that's in that region. But we'll do negative 3. So I'm going to do test negative 3. And go back to the original inequality and fill in negative 3 for x. I'm almost always going to go back to the original inequality, not the one where I changed it, because I changed it to an equal sign, right? I don't want to test that. I want to test the inequality. So I have negative 3 squared is less than negative 3 times negative 3 minus 2. This comes out to 9. That's going to be 9 minus 2, right? So 7. Is that a true or a false statement? 9 is less than 7. False. And so I'm going to put an X in that section on my number line, right there. Which means the numbers in this region to the left of negative 2 are not a part of the solution to this inequality. I want to test something that's in this next region here, between negative 2 and negative 1. What could I test? Negative 1.5? That'll work. Test negative 1.5. So negative 1.5 squared is less than negative 3 times negative 1.5 minus 2, replacing the x's in the original inequality with negative 1.5. Negative 1.5 squared is 2.25. And the other side comes out to 2.5. So is this a true statement? Is 2.25 less than 2.5?
Yes.
Yes. So that one's a check, which means this is a check. And that means that the numbers in this region are a part of the solution. So we have just one section left to test over here. What number do you want to test? 0. I'm like, again, it's basically just because it's easy. Anytime that one of my critical values is not 0, I'm going to test 0. It's quick and easy, so we'll do 0 squared is less than negative 3 times 0 minus 2. I get 0 is less than negative 2. That's a false statement, so I put an X there. And you can see that the solutions to this inequality are the ones that fall between negative 2 and negative 1. The way I'm going to write that answer is negative 2 is less than X is less than negative 1. That's the answer to this inequality. So the first step is to solve the related equation. I moved the 7x and the 4 over to the other side, so they're negative, made it equal to 0 instead of greater than or equal to 0. And solve. We get solutions from that. These are, remember, the critical values of negative 1/2 and 4. So those are the numbers I'm going to put on the number line. And I'm not making a full number line and putting any other values, just those values, because I want to figure out which region or regions are the solutions in. So I want to start, I'm going to test a number here in the region farthest to the left. What number do you want to test? I'd probably just pick negative 1. Did you choose negative 1? Or something else? Yeah, you chose negative 1? So I'm going to test negative 1. You can test any... You chose what?
Negative 0.4. Oh, negative 0.6.
That's fine if you chose negative 0.6 as well. I'm going to choose this. I think it's easier to work with. And see, again, I'm going back to the original inequality to do the testing. Most of the time, that's what I'll do. 2 is greater than... That comes out to negative 3. Is 2 greater than or equal to negative 3?
Yes.
Yeah. It's not going to be both of them, right? It's not going to be greater than and equal to. It's greater than or equal to. So it's one or the other? Yes, it's greater than. So that's true, which puts, that's part of our solution set. Everything from negative 1/2 and below. So we'll test this negative 1/2 to 4. I'm going to test my favorite value to test, a 0. But you could choose something else if you want it. 2 times 0 squared, 7 times 0 plus 4. That comes to 0 is greater than or equal to 4. True or false? False. So those numbers between negative 1/2 and 4 are not a part of the solution. I just have one more region to test. Over here, something that's bigger than 4. Choose whatever you want. I'm going to choose 5. So I'll go 2 times 5 squared equal to 7 times 5 plus 4. And I get 50 is greater than or equal to 39. And that is true. This one has 2 regions as the solution, so we can't write one statement like we did in the previous one. If there's one region, you can write one statement, but if there are 2 regions, you have to write 2 statements. So the statements would be x is less than or equal to negative 1/2, because that's all the stuff to the left, or x is greater than or equal to 4, because that's all the stuff to the right of 4. That's the answer. That's how you're going to have to write it out. 2 separate statements because there are 2 separate regions. x is less than or equal to negative 1/2, or x is greater than or equal to 4. You can't do it in one statement, and the reason is x can't be in both of those regions at the same time. It's either here to the left or to the right. It can't be both. Whereas when it's one region, it is both. Less than the upper limit and greater than the lower limit.